Hi everyone, how are you? Welcome back to Introduction to Algebra, and today we're in the fifth class. So that means that we're almost over with the whole course, okay? Today is going to be trigonometry, and it's going to be a short class. There's not much left to see, but it will be a really short class with just one break. So I had a great week. I'm a little sick because here it's really hot and I feel like I'm melting. I don't know how to explain it to you. And my cat is still fine. Okay. I would love to hear about your week. How was it? If you're getting happy because we're in December already, and that means Christmas is coming. It's just right around the block. I don't know if you do advent calendars. I would love to do them, but they are really expensive to me. So I'm really happy because, well, we're in December already. 2025 is coming around. So today we're going to talk about trigonometry and triangles. So first, what is trigonometry? Well, it's the branch of mathematics that studies the relationship between angles and sides of triangles, specifically right triangles. I have a little picture here. It's just for you to see, it's still just an image, okay? We're not going to go really in depth with that picture because it seems a little confusing, okay? So, what's an angle? Because we said that trigonometry studies triangles and angles, but what is an angle? Well, I have two definitions for you. The first one is an angle is a part of the plane bounded by two rays, side of the angle, that share a common origin called the vertex. Oh, so here you see a little triangle that it doesn't have one side, so it's just two vectors. We have L1 and L2. And here we have an O. So the little piece, that like a small triangle, that's the angle that we're going to study. So it's bounded by two vectors. And here we have a common origin, the vertex. So this is one definition. We also have another definition that given two rays, L1 and L2, with a common origin, like we said, the vertex, an angle is the portion of the plane created by the sweep rotation of L1 that lies with L2. For example, I have this, okay? You see my hand? We have L1 and L2. And if I go, I sweep it, I have this small part, and that will be the angle. The angle that my fingers make. Imagine that this is L1 and L2. That's the angle that we're going to study. In this case, I know it's a cute angle, like it's a small one. Here I will have a 90 degrees angle, and this, I can really do this because it will hurt my fingers, but this is a bigger angle, okay? So it can change, it can go smaller and bigger. It depends. So, given these two definitions, we can say that when we rotate counterclockwise, it's considered a positive angle. So when we go this way, counterclockwise, it's positive. But when we go clockwise, it's negative. So let's say I have this. If I go this way, negative. If I go this way, positive. Okay? That's something that we chose as mathematicians for us to be easier to study. Okay? So we need to measure the angles, like it says. We have different units to measure angles. It's not only one system. For example, I've seen sexagesimal and the circular system. And those are the ones that we are going to see. Sexagesimal system, also known as the base 60 system. So in this system, everything is 60, okay? So a circle, we know, is 360 degrees. So that way, when we divide each quadrant, we divide by 60. And, well, not by 60 and 90, but we know that a circle is 360. That's the way we count hours and minutes and seconds. An hour is 60 minutes. A minute is 60 seconds. An hour is an hour and a half, and 2 hours, I think, an hour and a half will be 90 minutes, and 2 hours will be 120 minutes, you know? It's always 60. And then we have the circular system, which we use pi to really use the system. So in this case, the angle is measured in radians, you know, rad. Really, we use this system more when we study like pendulums. We do not use this as a base for every day. For example, it's not like I can say like an hour it's 2 pi, you know. We say an hour is 60 minutes. We use a sexagesimal system. So circular system is more for a calculation, you know, math properly spoken. And then what happens if we want to have a relationship between these two? P radians is 180 sexagesimal, you know, so 180 degrees. And we can have this sort of conversion system, you know. An angle in the sexagesimal system will be 180 sexagesimal system, 180 degrees over p, over pi, multiplied the same angle, but in the circular system, okay? It's just pure mathematic for us to have a relationship between these two systems. Like I said, the sexagesimal system is more for an everyday use, you know? For example, when we are looking for coordinations, you know, I'm sure you have or know someone who plays Minecraft. We can locate different points with the sexagesimal system. Or for example, if you open Google Maps and you just get there and choose a random point, you will get obviously the address and also a sexagesimal pinpoint location. Let's say you chose, I don't know, France. It will be like 360 with the degree, 36 minutes and 62 seconds. I don't know if that's the location of France, but that's a way that we also use the sexagesimal system every day. But like I said, the circular system or the radian system is more for math, pure base math. So we have the Cartesian system, for example. When we want to draw something, we need to have a paper. And we can divide a paper in different planes. The Cartesian system, for example. Let's say I have a square and I want to have 4 same sides. You know, I want to partition this paper for my friends. I will like fold it in half and then again in half, like this drawing that I have here. And we can have them in quadrants, for example. This is a mathematical framework for representing points, lines, and geometric figures using a grid defined by 2 perpendicular x's. So we have an x, and this x is going to separate our paper. We have the y axis, the one that goes vertical up and down, and the x one, the horizontal one. We go right, we go left. So imagine we are three-dimensional beings. We live in a 3D world, you know, we have that, we can touch things. But if you were a drawing on paper, you could only go this ways, you know, right, left, up and down, forward and backwards. No, just these sides, okay? So we are working in a two-dimensional setting, okay? So the x-axis, horizontal, y, vertical. And the way that we have to divide this plane is in a 90 angle degree. So the first quadrant, here I have it, will be x, it's bigger than 0, and y, it's bigger than 0, which means that everything is a positive number, okay? X can go from 0 to 90, I don't know, and not 0 to 90, but 0 to infinite, but always positive. And y can go from 0 to infinite, but always positive. That will be the first quadrant. And when we see this, we can see that's a 90-degree angle to the vertex here in the middle. Now, we tend to count things clockwise. So we may think, well, the first quadrant is here. So the second one will be here, but no. The second quadrant is behind the first quadrant, in which x takes values that are negative, so from 0 to minus infinite, and y goes from 0 to positive infinite, okay? So when we are here, we are standing. If we go to the right, we'll be in the first quadrant, and if we go to the left, we'll be in the second quadrant. Well, we also going upward, okay? Now, we always count counterclockwise, so this way. Then we have the third quadrant, in which x is negative and y is negative. So everything is negative, you know? You're going down and you're going to the left. And then we have the fourth quadrant, in which we're going to the right and we're going down. X is going to be positive, but y is going to be negative. So in a way we can say the first quadrant, we're going right and up. The second quadrant, we're going left and up. The third quadrant, we're going left and down. And the fourth quadrant, we're going right and down. You know, it's a simple way for you to remember, okay? And those are the quadrants in which we divide our Cartesian plane. So if we're going to use the degree system to divide the angles, we'll have 90 from 0 to 90. From 90 to 180, to 180 to 270, and 270 to 360. Okay? So 90, 180, 270, 360. Okay? That's the way we divide it. It's simple. It's quite simple. And if you say, well, I can't remember the numbers, remember, you need to always add 90. 0 plus 90 will be 90. 90 plus 90, 180. 180 plus 90, 270. 270 plus 90, 360. Okay? It's a simple way for you to remember. Now, I know we're going a little bit fast today, maybe. I have to work in a few minutes, but I wanted to tell you about trigonometry, obviously. Now, we have relationship between the angles. It's not just any angle, you know. You may know, or you may remember sine, cosine, and tangent, okay? So, I have two triangles. They are the same triangle, okay? They are the same rectangle triangle. Now, I have two versions of the same triangle because I want you to understand that if we see the triangle in a different position, sine, cosine, and tangent, they change. So the opposite side is the opposite to the one that we are standing on. So imagine, let's take, for example, the triangle on the left, okay? You see where I drew the eye? Let's see in a way that we are standing there, okay? We are just standing here, okay? Now, the opposite side, it's going to be the one that we're facing. So if I am standing here in the C, the bigger C, you know, the uppercase C, I'm going to be seeing the small c, you know, uppercase, I don't remember the other word well, but the small c, you know, that will be my opposite angle, my opposite side. I'm going to see it right, okay? So if I'm standing the big C, my opposite will be the small c. And then we have the adjacent. What is the adjacent side? The adjacent side is the one that it's right next to us, but it's not the hypotenuse. So if I'm standing here and I reach with my arm, I'll be touching the hypotenuse and the adjacent side, which means the hypotenuse will be the larger one, you know, the one that's larger than everything. And the adjacent will be the one that I'm touching. In this case, if I'm standing here in the C, my adjacent will be A. I will be touching A. That means my hypotenuse will be B, okay? That is if I'm standing here in the I. Now, if we know which sides are my opposite and adjacent, we can say sine, cosine, and tangent. So this is a Greek letter. I don't remember the name of it. I'm not really sure. But we are going to call it Y because it looks like a Y. So if I want to go sine of Y will be opposite over hypotenuse. Like I say, I'm standing in the C. My opposite, small c. My hypotenuse, small b, which means that sine of y will be c over v. Now, cosine, almost the same. Cosine of y will be a, my adjacent, over b, my hypotenuse. Okay? And tangent will be opposites over adjacent. C over A. Okay? That's if I'm standing here in the I in the left. But what happens when I go to the other triangle, the one on the right side? So assume that we are standing here in the A. The right side of the screen, you're going to see a triangle and the I, and I'm standing there in the I, in the uppercase A. Now, why did I do this? So, why did we do this? Okay, why I'm standing in the uppercase A? Because I wanted to teach you that depending on where you're standing, on which one is your main angle, sine, cosine, and tangent will change, okay? It's not always the same. I see kids who have problems with triangles because they can't fix or they don't know which one is the opposite and adjacent. So in this case, I wanted to show you both. What happens if I stand in the C and in the A? So in this case, we're in the right side of the screen. We're standing in the uppercase A. So if I'm standing there, which will be my opposite side? If I look straight up, smaller A. The A that's lowercase, that will be my opposite side. And my adjacent side will be the one that I'm touching. So I know the hypotenuse is B in this case because, well, it's the largest. So if I reach with my hand, I'll be touching the C side, the small c. You see, in the other triangle, my opposite was small c, but in this case, my adjacent is small c. So it changes depending on which one is your main angle. So remember, now, my opposite, A, my adjacent, C, and the hypotenuse still B. I'm sorry. So now this angle will be alpha. So sine of alpha will be A over B. Cosine of alpha will be C over B. And tangent of alpha will be A over C. Okay? So you see that sine, cosine, and tangent are always the same basic formula. What changes, it's depending on which one is our main angle. So if we're standing in the y angle or the alpha angle. And I want you to really take a look at this because this is really important. Most kids have trouble when they're drawing triangles because they don't know which side they need to take or which side they need to stand on. You see, that's why I told you, if you stand right in the C, your opposite will be lowercase c. If you stand right in the A, your opposite will be lowercase a. Okay, that's a convention that I use, uppercase, lowercase, because it's easier for you to remember. Okay, so when you need to solve a triangle, you need to see which one is your main angle. Okay, so here I have more math, pure math. Basically, I have a Cartesian plane here with r being just a vector. And I have a small angle here that's alpha, okay? This is more for you to know, like we have the Pythagorean formula here. X to the power of 2 plus y to the power of 2 equals r to the power of 2, in this case. And if we divide both sides by r, we end up with the identity. Sine to the power of 2 of alpha plus cosine of the power of 2 of alpha equals 1. Obviously, the angle needs to be the same. This is just an identity. You don't need to know this right now, but it's just for you to know. And then here in the lower case of the PowerPoint, I have the arc sine and arc cosine, because that way you can also know the angle. For example, in the last PowerPoint here, we saw that we are working with the sides, not the angles. Now imagine I know the angle, but I don't know how long is the side. That's why we use r cosine or r sine, okay? So I know sine, I know cosine, it's alpha. Cosine of alpha equals c over b. Adjacent over hypotenuse. We're standing here in the uppercase A. I drew this I for you to really get it. Okay. So cosine of alpha will be b. So alpha will be r cosine of b. This right corner here, this corner in the left. Now imagine alpha sine of alpha equals 0.5. If I want to know what's the value of alpha, the angle, I will have to use arc sine of 0.5. That will mean the angle here, alpha, it's 30 degrees. So we're working with sides, and I want to know what number is the angle, how many degrees. That's why we use arc sine and arc cosine. Now, that was a lot, wasn't it? It was. So, most of the time I've seen kids with problems in trigonometry because they do not know where to stand or what's arc, sine, cosine, tangent, always. I know that in Spanish we have a saying for us to remember. If sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent, So in Spanish we have a saying, but I didn't see a saying in English, which was weird because I thought you had one. So now we are going to take a small break because there's not much PowerPoint left, but we're going to talk about triangles. Okay. In this case, I just had the rectangle, triangle, and the one that's with the bigger angle. I didn't have the isosceles one because I don't think it's really that important in this case for trigonometry. Most of the time, I've seen people use oblique triangles and rectangle triangles. So, triangles. I have two here. The rectangle one that we've been working with, in this past slides, we've been working with this one. And in the bottom of the PowerPoint, we have the oblique one. Now, what's a condition for it to be oblique? Well, one angle must be over 90. Rectangle, triangle, you have one side that's 90. And in the oblique one, we have one side that's bigger than 90. Let's talk a little bit about triangles. So when we have a rectangle triangle, we have a 90 degrees angle. And if we assume this triangle is perfect, this rectangle triangle, it's perfect, the other two angles will be 45 degrees. Now, that's a rectangle triangle. But what happens when I work with an oblique triangle? Well, the angle that's bigger than the other two will be over 90, which means it can go from 90 to, 120. it can't be 180 because you will have just a line, But for most that I've seen are 90 to 150, I think what's the bigger one. But what does that mean? That means that the other two angles must be smaller than 45. They cannot be 45 or over. So, why is that? Well, that's I don't know if a theorem, but I think it's more of a law that when you add all the angles inside a triangle, it must add up to 180. So let's go to rectangle triangle. 90 plus 45 plus 45 will be 90 plus 90. 90 plus 90, 180. So it happens. It's a law. It always must be right. Okay. That's why when we're working with an oblique triangle and the angle is over 90, it's almost impossible for us to have another angle that's 45 or more because it will be weird. Okay, so we cannot apply the same formulas to both triangles. The one in the upper part of the slide, the rectangle triangle, we can just use Pythagoras system, Pythagoras formula. And like I said, that the sum of all angles must be 180. But in the lower part of the slide, we have more theorems, okay? We have the sine theorem and the cosine. The sine is the one that's a over sine of a equals b over sine of b equals c over sine of c. And in the bottom is the cosine theorem. I wrote sen because in Spanish is seno, so I forgot that it's sine in English, sorry. But it's the same. And here I have two problems. We're going to go each one of them. So, first one, to calculate the height, h, of a pine tree. Given that standing at a distance of 100 meters from the base of the tree, A, the angle between the line of sight to the top of the tree and the ground is 38 degrees. So what does it mean? I'm standing here, and I see a pine tree 100 meters from me, like straight up. And I say, you know what? I wonder how tall is that tree? So I look up, and I see the crown of the tree, like the top part of the tree, like really, really, really big. And I say, I wonder how tall is it? What do I do? I know that if I stand here, the angle that will form between my line of sight and the top of the tree, like this way, is 38. Now, I'm standing 100 meters away, and the angle that I'm writing here is 38. Imagine I'm standing here in the uppercase C. Okay, so I'm standing, see the tree? I'm 100 meters away, and I have a 38-degree angle. I say, okay, I know the angle. I know my adjacent, here, my adjacent side. I want to know my opposite side, which will be h, and I know the angle. So what relationship, what sine, cosine, tangent I know that has a strict relationship between opposite and adjacent side? Tangent. So the tangent of 38 will be opposite over adjacent, h over 100 meters. So I work with it. We've been working with this type of mathematical formulas for a long time now, so I bet you know how to solve this. So h is 100 multiplied tangent of 38 degrees. We're not working with rad, we're working with degrees. We solve and we know that the tree is 78.13 meters. It's really tall, like really, really, really tall. But that's a way that we can work with these numbers. So I'm standing and I think I'm almost cracking my neck because I'm like, wow, it's really tall. So this is an example of a rectangle triangle used in a problem. Now, these are the easiest one. Okay, these are really easy. We can just work with them. But what happens when I have an oblique triangle? I'm glad you asked. I know you didn't ask, but I did. So this is not a problem because most of the time we can solve problems with that rectangle triangle. If you study physics or an engineering, I think, you will have relativity problems in which, like, for example, I'm standing in front of a river and I see a swimmer swimming, and I want to know the angle that they should be swimming for it to be this way. So those problems are really weird. Okay, so going back, we have an oblique triangle. Solve the oblique triangle and calculate. It says calcite. I know it's calculate its area given the measurement of one side a over equals 30 meter and the two adjacent angles beta equals 68 minutes 68 hours 10 minutes and y 15 hours 20 minutes. So I'm standing here in the lowercase a. I'm standing here and I can touch to my right beta and to my left y. Okay, so I have these two angles. Here you can see that A, it's another angle that I do not know. But if I remember correctly, I said before, if I add all the angles inside a triangle, it must add up to 180. And here's what I'm seeing. A equals 180 minus B plus C. So A is 95 hours, 30 minutes. Now I have all angles. And I'm allowed to use the sine theorem, sine formula. A over sine of A equals B over sine of B. If I want to know how long is B, I have A multiplied sine of B over sine of A. And I just switch numbers and I know B is 28.03 meters. And it's the same procedure for the C side. Now, I don't have it here in my drawing, but I can help you visualize which side is B, A, and C. We know A is already written here, the lowercase a. That's the side I'm standing on. So my opposite angle, the one that I'll be facing right on, it's the uppercase A. So if I stand on C, the angle, 15 hours, 20 minutes, the side that's C, lowercase c, will be the one I'm right facing, That side is the one that's in between A and B. And if I go and I stand on V, the side that will be lowercase b will be the one that I'm facing right on. That means that's the side that's between uppercase A and uppercase C, that side. Okay, so if I go back and I stand on lowercase a, to my right, I will have the angle 68 hours, 10 minutes, and that side will be lowercase b. To my left, I have the 15 minutes and 15 hours, sorry, and 20 minutes angle. And that line over there will be lowercase c. That's 7.98 meters. Now, it also says that I should measure the area. So, in this case, the area of this triangle will be A multiplied B over 2 multiplied sine of C. And we just change the values and we have the total area of this triangle. So It's not really that hard, you see. It's more of a where do you stand, you know? If I stand on this side, which one is my opposite side, which one is my adjacent side. But these are ways for you to help you calculate triangles. We could have we could have divided this triangle if we wanted to. I don't really recommend that because I think it's getting you into more trouble than you already are. So I'm sorry if you hear that. It's my neighbor with a chainsaw. So that was everything for this class, really. Trigonometry is really short in comparison. And the next class, we will have our final class. Um, it will be a revision that of what we did up until now. I will go over it not really fast, but I will try to find a problem in which we use everything that we learned here. Maybe it will not be one, but rather two. So I hope you learned everything. I hope you enjoyed yourself here because I did. I love teaching. Even though I sometimes get a little like twisted, like I don't know what to say or when to say because like English is not my first language, but I enjoyed it here. So that will be everything for today. I hope you had a great week and I'll see you in our last class next week. See you.